welcome back for the last talk before we have lunch. Would you please join me in welcoming to the podium Clinton Roy, who'll be talking about adding file system context to pathlib.
It's always helpful to get a reminder of what is between you and lunch, so no pressure. Hello everyone, my name is Clinton. I'm a software engineer. Most of my career has been around helping researchers write code so that they can do more research and more science and make life better. At the moment, I'm at the Australian Synchrotron. A few of my colleagues have given a couple of talks earlier in the week on the synchrotron stuff, so I don't have to go over that, fortunately. I'm talking today about something that is not synchrotron specific, but it certainly has come up from some of my work at the synchrotron, and it is a very small tweak to Python that I'm suggesting. And you know, as with any change, the change is the hardest part. During this talk, I'm just going to outline what I'm proposing, why, how it could be implemented, and what are the next steps. There is a public part of the Python community, a public website called Discuss. There is a section of that called Python Ideas. I'm trying to choose my words very carefully here. Python Ideas is a place where ideas go to get schooled. A lot of people have ideas, they think they're really good. Many people have ideas, and they're much like getting a song stuck in your head. They're stuck in your head, they're not stuck in everyone else's head. They might sound really good inside your head, but when you sing them, they sound really bad. Ideas can be really similar to that. They sound really good in your head, but they're not so crash hot when everyone else looks at them. There's roughly, I forget the exact number, I think there's roughly about 50 or 60 threads of ideas posted to the Python Ideas forum a year, and most of those ideas, the response to them is like, the last person who brought it up, here's all the responses to it that said it's a really bad idea, go and have a look at this thread. Or even more concretely, that idea was proposed in the standard Python way, a PEP, which we'll get onto later on. And these are all the reasons that PEP didn't proceed. So whenever I have an idea, because I subscribe to the Python Ideas mailing list, I know how to set my expectations for any ideas that I come up with, and they are low. So I had an idea, and much like a song, I couldn't get it out of my head. And it was rattling around, and no matter how many side projects I said yes to, I couldn't get rid of the idea from my head. So I decided to post it up on Python Ideas and let other people shoot it down so that I could quietly put it to bed. So, you know, I freely admitted that I was using a public resource. I was using other people's time for my own mental health. Unfortunately, someone came back and said, that's kind of an interesting idea and you should do it, and then he listed out a technique for doing it. If you don't know Barney, this is the code owners file from CPython GitHub. Barney is the owner of the pathlib library. So unfortunately, I posted an idea, and the person who owns the library said, it's an interesting idea and you should go and have a look at it. So that was the first fail. So I'm not really suggesting, it is a very small idea, as you will see. I'm not suggesting huge code changes. So most of the coding examples I'll be showing will be relatively small. For space reasons, you can assume that all of the examples have this import here, just so that we can save on space going forward. So it's a very standard import of path from pathlib. And the change that I'm suggesting here is there are flags that are passed to operations in pathlib, and the most common ones are to do with case sensitivity and to following symlinks. And I'm suggesting that we move those flags from the operation, so from the verb, and we move those flags to the noun, so to the object. So in this before case here, pathlib has a glob operator. So we're asking pathlib to give us all the star.tiff files. And if I say case sensitive false, it will give me all of the star.tiff lowercase files and all the star.tiff uppercase files. And if one of the elements of home Clinton R Pycon AU is a symlink, I'm telling it to not follow those symlinks. So if there's a symlink in that path, don't follow it. So all I'm suggesting is we move those flags from the operation to the object. There is a little bit of a name difference between the recurse symlinks and the follow symlinks. The concept is identical there. So don't get hung up on the name of the attribute changing too much. So that's the talk. So if you need to go off and have lunch, you've got the guts of the idea. And I kind of have to describe why we want to do this now. So if your stomach's nice and comfortable for lunch now, I'd leave now because this is where it starts to get a little bit queasy. I am a developer. I'm therefore right. So this is the essential core problem when people post their ideas up to Python ideas. This is the core motivating factor that they've got. This is the one that you've got to get over when you post your ideas in public. I think long term with pathlib, we're just going to start seeing more and more flags. And I think those flags are good. So having those flags to be able to change the way that operations happen, I think is a good thing. But I think it might be a better thing if we have one place where we put all of those flags, rather than adding flags to lots of different operations. And that's a little bit of a taste thing, but I also think it means that when we add a flag, we are not just adding a flag to one operation. We're thinking about how that new flag can alter the behaviour of the entire pathlib library. And it means that if we add a new flag, we're adding it in one place. So the documentation for the pathlib init function would grow all of the flags, but none of the other operations would grow in their complexity. The main thing I think here is that it's very possible to have paths as parts of an API where you're passing a directory along to an API, and that API, you don't want to have to give it all of these extra flags as part of that API, because the path is really just an input or output operator, and you don't want your non-path API to have to deal with those flags. So this is where the work side of things come in. Let's say I have a science API that I give a directory, and that directory might have, I don't know, hundreds of TIFF files from a camera that I control. At the moment, my science API would, if there were symlinks in that path, because it was a nested NFS mount from 3 servers away and there were lots of symlinks in that chain, at the moment, I would have to tell my science API that doesn't really care about symlinks that it needs to follow the symlinks. So if I get my change in, that option would get passed along to the path object. The science API wouldn't have to think about symlinks, wouldn't have to know about symlinks, but it would get modified by those flags. And in my mind, that's appropriate, because my science API doesn't know what symlinks are, shouldn't have to know what symlinks are. So it's that separation of concerns in the API. So as well as Barney saying it's an interesting idea, he also gave me a complete recipe for how to go about implementing a prototype. So the rest of the talk is going through that prototype. So I am making a class called context path, because all of these flags are context in a certain way. In the fullness of time, if this idea was accepted, there wouldn't be a context path, it would go into path itself. But for this test run, we're making a new class called context path. The really important thing here is that in Python 3.12 and 3.13, Barney's done a lot of work to rejig pathlib so that you can subclass from path and do so in a really useful manner. So if you want to do experiments around path and pathlib, it is really easy to do. So much so that he's kind of got a rote response about how to try these things out. So, the second implementation step is passing along my context flags to the init operation. So my init operation here, very standard Python, where I've got my star args, which is all of the parts of the path. I've got my case sensitivity flag, my follow symlinks flag. I call super of init, so that's the path init, so that initializes path how it always has been, and then I store my flags in the object. So very, very normal, standard, basic Python there. Step 3 is implement with segments. With segments is the workhorse of the pathlib path object. Anytime you are making a new path based on a previous path, like you're using the slash operator to add a new directory or file name into it, it eventually gets called down to with segments. So the path implementation of with segments is really quite clever. It grabs self, asks me what the type of self is, and in path, that answer is path, and then it passes along those path segments to its own class. So it's calling init again, essentially. So my context path implementation, very, very similar, does exactly the same thing, but just passes those flags along. So I'm doing exactly the same thing as the original path class, but I'm just passing my context flags along. I can't hear anyone's stomach rumbling or anything like that, so that's good. So that's essentially the implementation, like a test implementation of my idea in terms of creating a context path, passing the flags along. Now it's time to use the flags. I'm not, like the really important thing here is I'm not talking about changing the behavior of pathlib, I'm just talking about changing the way you configure pathlib. So, one of the operations that pathlib does is a stat. A stat asks for information about a file or directory that you're pointing to. So, the implementation of stat, I can call that in my context implementation of stat by calling super.stat. And when I pass, so stat already has a flag on the verb to follow symlinks or not. So all I do in my implementation is grab my internally stored flag self.follow symlinks. So I'm not changing the operations of anything, it's just how and where the flags are stored and passed along. And similarly with glob, where we're looking at globbing star.tiff files before, very similar. I call the current implementation of glob, but I just pass along the case sensitive and follow symlinks flags from my own internal flag registry memory. So, to think about how this would operate for testing, we have a testing directory here. We've got two TIFF files here, one's lowercase, one's uppercase. So when we switch the case sensitive flag and we do a glob operation, we'll expect to either get one or two TIFF files there. And we've got a destination dir at the top, and we've also got a symlink pointing to that des dir at the bottom. Don't worry, the context important parts of this slide will be presented further on, but I've only got 4 files that I'm testing with, just as a proof of concept test. So now we look at some basic tests for context path. So again, these are common imports. So stat is a standalone Python module. It's a built-in Python module. When you do a stat on a file or directory, you get back a whole bunch of numbers. Stat essentially has a whole bunch of constants that let you ask, is this file thing a file? Is it a symlink? Is it a directory? And for my tests, I import context path as well. So these are just imports that are repeated for all the tests, and I've just put them up here to save space further on. So this is a case-sensitive test. So this is the subset of the test area that we're interested in here. So we've got the lowercase TIFF file, the uppercase TIFF file. We create our context path. We pass along case-sensitive true, so we care about the case. When we do a glob on star.tiff, and that is a lowercase.tiff, we expect that we'll only get the lowercase image.tiff file back. So that's our case-sensitive test there. And very similarly, same area with the two TIFF files, uppercase and lowercase. This time we set the case-sensitive option to false, so we don't care about case. So this time when we do a glob on star.tiff, it will glob on both the lowercase and the uppercase. You can see it, the assert there, we expect to get those two files back. So that's the test. So we've tested the on and the off parts of the flag. Symlinks are a little bit harder to reason about, to think about. I'm a Unix person, and I know through many years of experience that I get them wrong all the time. So this is the test for following symlinks when we're doing a stat operation. The subset of the test area that we're interested in here is the destination dir, so it's a directory, and the symlink that points to that directory. We make a context path to our symlink, and we say follow the symlinks, and then we do the stat on that. So because we're following the symlinks, when we do the stat, we won't be doing the stat on the symlink, we'll be doing it on the destination directory. So when we ask the stat results, is it a symlink? It'll be false because we're following the symlinks, so we'll actually hit the directory. And when we ask the stat results, is it a directory? Because we follow the symlinks and we've hit the directory, it will be. And similarly, where we're in a mode where we don't want to follow the symlinks, where we want to halt on the symlinks, it's kind of switched. So we pass along follow symlinks to be false, which means that when we're doing the stat, when we're realizing that path, it'll stop at the symlink. So when we check the stat result, we can see that it is a symlink and that it is not a dir because it hasn't followed that symlink through. And I don't think I'll tell you how many times I had to do this test until I got it right. So I've got the idea, I've got a very basic implementation, I've got a conference talk out of it as well. So what's the next thing to do? Now that I've got a really basic implementation of the idea, I need to get back to Barney, show him the code, see what he thinks. And that's kind of like the code's the really easy part. Like the point of this talk is to show that, you know, software a lot of the time is really easy and it's dealing with the people and the change management that's really hard. So the next, so assuming that Barney likes the code and wants to go ahead, now we have to think about how we're going to incorporate this change into the Python ecosystem. The structured way of doing this in the Python community is with a Python enhancement proposal, or PEP. It's a structured document which talks about all of the technical challenges of the idea. It explicitly brings out how we're going to teach this change, because at the roots of Python, it was designed to be a language that's easy to teach. So if you're making a change to the language, you have to outline how you're going to teach this change, which I think is a very useful thing. But there's also thinking about backwards compatibility, because it's a change. So we're going to, you know, if this gets up, it's going to change how people use pathlib, and we have to think about all of the code that's out there that uses these flags on the verb, and how we're going to migrate to having the flags on the noun. Do we have the flags in both places? Do we deprecate them? Do we think about eventually removing them? Do we use the tri-state nature of these flags, where by default they're none? You can actively set them to true or false. If one of the flags is none and one of the other flags is true or false, does that override things? Or does the verb always override the noun? Or does the noun always override the verb? There's lots of options. And fortunately, I won't be in charge of making that decision. So if we go down this track, it's one of these changes where it sort of opens the door just a crack, and you can sort of see through all of the things that you would do with it. So the buzzing in the brain, this is like the flapping in the brain versus the buzzing in the brain. So Windows has things that behave like symlinks, but regular users don't have the privileges to use them. They do have things called junctions, which are kind of like symlinks, but they're only, if I'm remembering correctly, junctions are symlinks that you can only point to directories, and you can only point directories on the same file system. There's already code inside of pathlib to check if something's a junction, and part of my impetus for doing this is, instead of adding a follow junction flag to all of the calls that it makes sense, we just add that follow junction flag just in the init function, and we call it done. There's lots of fun things with lots of different Windows operating systems where the path can be encoded with different Unicode mappings and different pre-Unicode mappings, so that you can have nicely spelled human names in file names and directories. At the moment, Python sort of takes a punt on that and says, we always do this, which is totally fine, totally legit way of doing things. But if we had options on path, we could set those options and we could get nicely printed names out of paths on Windows that our users like to read without having to do any work. One of the things with symlinks is that it's very easy to do a really long chain of symlinks, ping-ponging all around your file system. You can get into loops quite easily if you forget which way around the operators to creating a symlink go, which I never did that anymore. So it's very possible to request following symlinks, attempt to open up a file on a symlink, and just go round and round in a loop. Now, if we let that happen, that would be a nice way of doing a denial of service attack on some code. So the security people have added limits to the underlying file system code that says, if you're following symlinks and you hit 100 symlinks, that's it, we fail, and you can't open that file. Wouldn't it be nice if at the Python layer we could do something similar and say you can only follow 10 symlinks at the Python layer? So that would be an interesting way of doing security stuff at the pathlib way. There's lots of things to think about from the backwards compatibility point of view, and I've already mentioned this, like what would take precedence? Would the noun or the verb flags take precedence? Do we use the tri-state nature of these flags to make things nice? Would we actually deprecate the arguments on the verbs, or would we just leave them there as an optional extra for those times when you do actually want to override? If you're writing a program or an application and you've got lots of paths coming in and out, maybe for that application or library, you want to always have the same flags for all of the paths that you create. So maybe we provide a path factory that sets all of those flags. Maybe that's something to think about. So that's essentially the talk. I like using old technology. This slide deck was made with Emacs and org mode and LaTeX and TXZ. The new thing for me is I've actually paid for a typeface, which is a sentence that I never thought I would say, but the mono typeface there is courtesy of Berkeley Mono. And with that, I have time for questions.
And who's up for the first question? Yeah.
No.
Come on, you knew I'd ask something. So you already answered my first question, which was the default flag model. But the other thing that was giving me vibes of was decimal contexts and whether you'd considered the decimal context type approach.
Yeah. So similarly, programming is, not all the time, but a lot of the time it's about making assumptions versus knowing the assumptions that you've made. So we've done that in a lot of contexts, and one of these contexts is with decimal numbers. So there's a whole bunch of flags that you can set around dealing with Python decimal numbers. And this is not a Python-specific thing. This is the standard for decimal numbers that the Python implementation bases itself on. But in order to make life easy, we hid a lot of those details inside the module. Now, I might be getting this wrong, so shout me down if I am. It's difficult because those contexts are built into the module. It's a little bit ugly to change those contexts for two different decimal numbers and get them to talk together nicely. So I don't know. Like in my mind, the decimal context way of doing things is not great, and maybe shouldn't be a recipe for how we do this in the future. But that's in an attempt to make decimal numbers as easy and as nice to deal with integer literals, we hid some of the context. It's still available and you can still get it, but it's not as nice as it could be. I don't know if you agree with that or not, but yes. And fortunately, I don't have to make that decision. I think we've got one right at the back.
Oh, yep.
I'm glad that the video operator didn't invent a cute way of communicating to me with the video recorder.
I don't have a mic. They didn't give me one. They don't trust me with it. I wrote my question down because I forgot it immediately. I know you told us to disregard the rename of Eureka symlinks to follow links.
Yes.
Is that rename partially so that it is easier to introduce that number limit, or is it also just to make it clearer that it is stopping any symlinks rather than like? Yeah.
So it's very possible that we would need to think. Well, we would need to think about the naming of these flags. If we change the location of the flags, we'd need to think very carefully about the naming of them. So it is entirely possible that without me thinking of an explicit case of it, that we might have two symlink flags that mean slightly different things for different operators. That's entirely possible. And that option is in the back of my brain. I can't think of the case, but it's entirely reasonable and possible that will happen.
Hi, you mentioned a few potential future options on paths like junctions and Windows encodings. Is that something you start off the conversation with the code owner of, hey, I've got a bunch of ideas and this is a prerequisite, or do you just take it like one step at a time and see how far you get?
I would give Barney probably like this talk video, basically. So I'd give him the code and the talk, and I'd sort of suggest, these are all the things that it might improve things. Barney will have a much better idea of what the right way to go is for these things. None of this stuff is really, well, all of these things are possible with Python now. It's just that you've got to do explicit code handling in your paths and around your path handling. And I think Python could be nicer if some of that stuff was automated using the contexts.
Thank you very much, Clinton. I present to you the mug. Oh, and then Mike Clinton.